In this video, we'll be covering section 10.3 on the parabola. Make sure to have your Unit 5 formula sheet. Remember this part here over the circle and the ellipse were over 10.1. The hyperbola section was 10.2, and now we'll be working with these set of equations in 10.3. Although we did graph parabolas in college algebra, we will be adding a parabola that has an axis of symmetry along the x-axis. The way that we represent our formulas for this section will also be different, but some of the rules still apply. So if you recall, whenever we had a value of a that was positive, we said it opened up. If the a was negative, it opened down. We also identified the vertex, which is located at our either maximum point or the minimum point. But now we're also going to introduce the focus and the directrix. So a parabola is the set of all points on the plane that are equal distance from the fixed line directrix and that fixed point focus. So if you notice on here, you can see that the distance from the focus to any point on the graph is exactly the same distance as the point on the graph perpendicular to the directrix. These two distances are the same. The shortest point from the focus to the graph and the graph to the directrix is called P. Here is the standard forms of the equations of a parabola with the vertex at the origin. Remember, we will not be using these equations. I'm going to be giving you the equations where the vertexes is at H and K. You will also not be getting these graphs shown. If you notice, there's a note at the top here, and it says that we are accustomed to writing the equation of the quadratic function where the vertex is in the form like this. Now, the benefit of writing it like this is we can identify the value of P, which gives us the distance between the vertex and the focus. Number 1 says, to graph the parabola described by y squared is equal to 8x. We are going to find the focus and the equation of the directrix. Let's go ahead and begin by looking at our formula sheet. The first thing I want to do here is identify if my axis of symmetry is vertical or horizontal. Because we have a y squared listed here, we know that our axis of symmetry will be horizontal. So I'll be using these set of equations and then covering up the other sets. Since I know I'm using these equations here, I want to be able to identify what our vertex is. If you notice, our vertex is going to be located here, which is 0, 0. So I'm going to start with that. Our vertex is 0, 0. That means H is equal to 0 and K is also equal to 0. If we plug in our 0 for H and we plug in our 0 for K, we are going to be given a value of y squared equals 4p times x. So we can say that 4p is going to be equal to 8. So 4p is going to be equal to 8. Solve for p by dividing by 4 on both sides. So here our p is going to be equal to 2. We need to know what our p is in order to find the focus. If we notice here, the equation for our focus is going to be h, which is 0, plus p. So 2, comma, k, which is 0. So this is going to be our focus. The directrix is going to be equal to this equation here. So I'm going to put directrix is x equals h, which is 0, minus p, which is 2. So x equals minus 2. This right here is a very important note. In order to determine how wide the graph of the parabola is, we can determine the length of the line segment passing through the focus perpendicular to the axis symmetry with the endpoints of the parabola. We will be calling the length of this line the focal diameter. which is equal to 4p. Let's go ahead and use this graph here to see how this works. So we determined that our focus was at 2, 0. So I'm going to go ahead and plot that point. 1, 2, 0. Okay. What this basically is saying is that the distance going between the end of the graph all the way to the other end of the graph will be 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. The distance of the graph going through the focus is going to be 4p. So this distance here is 8, and I just verified that it is indeed a length of 8 units. Number 2. Number 2 says to graph the parabola with the vertex at the origin. That means our vertex is going to be at 0, 0, or in other words, h is 0 and k is equal to 0. It says graph x squared is equal at 16y. We're going to identify the vertex, which I just did, the focus, and the focal diameter. Using our formulas, the first thing we want to do is identify which set of equations we'll be using. Since we have an x squared here, we will be using a vertical axis of symmetry equations. So I'm just going to cover up the other set. We already identified our vertex to be 0, 0. Let's go ahead and move on to our focus. In order to know our focus, we have to identify the value of p. Remember, 4p is going to be equal to 16. So I'm going to start with 4p is equal to 16, which means p is going to be equal to 4. So let's go ahead and write our focus. Our focus is going to be h, which is 0, comma, k, which is 0, plus p, in this case, plus 4. The next thing we're going to do is find the focal diameter. If we look at the equation here, our focal diameter is equal to 4p. So I'm going to go ahead and put the focal diameter is equal to the absolute value of 4p, which in this case is the absolute value of 4 times 4, or in other words, 16. Given this information, let's go ahead and graph. We know that the vertex is at 0, 0, so I'm going to go ahead and put that there. Our focus is at 0, 4. I'm going to stay here and go up 4. 1, 2, 3, 4. Here's going to be our focus. I'm going to label that with an F. Now what I'm going to do is use our focal diameter, and we know that the graph is going to be the length of 16 passing through the focus. Since we want it to be equal on both sides, I'm going to go out 8 units each side from the focus. So here I have 1, 2, 3, 4, 5, 6, 7, 8. Here's one end point, and the other one will be 1, 2, 3, 4, 5, 6, 7, 8. Here would be the other end point. So now you can see the basic shape of our parabola. I'm going to go ahead and draw it. So here are the endpoints of our focal diameter. Location is here and location here. So I can see that this is -8 and then up 4. -8 and up 4. The other one is going to be located here, which is +8 and then up 4. Let's go ahead and find the equation for the directrix and the axis of symmetry. For our directrix, we have y is equal to k, which is 0, minus p, which is 4. So here our directrix will be y is equal to -4. If I want to draw this, you will see that this equation here is a horizontal line. Y is equal to 4 is 1, 2, 3, 4 located right here. So this is going to be our directrix. If I notice the perpendicular location from this endpoint down should also be the distance of 8. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. It works. So this graph is correct. Let's find our axis of symmetry. We're going to use x is equal to h, and h is going to be 0. So our axis of symmetry is on the y-axis, and if we fold this in half, you will see that these 2 points will definitely meet. Number 3 says to graph 3y squared is equal to negative 36x. We're going to identify the vertex, the focus, and the focal diameter. Let's go ahead and rewrite this equation so it matches the standard equations for a parabola that we have here and here. Notice that these do not have a coefficient in front of the x squared or the y squared. 3y squared is equal to negative 36x, and divide everything by 3. So we get y squared is equal to negative 12x. Now that I have my equation, I'm going to go ahead and choose the set of equations that it resembles. Since this is a y squared, I will be using these sets of equations right here. Let's go ahead and cover up the other sets. What I'm going to do is go ahead and identify the vertex first. Remember, the vertex is going to be h and k, and if you notice over here, there's no numbers associated with the x or with the y, so our vertex is going to be 0, 0. That means our h is 0 and k is equal to 0. For the focus, we need to determine what our p-value is. Remember, when it's in this form, the coefficient here has to be equal to 4p here. So 4p is equal to negative 12. P would be then equal to negative 3. The negative tells us that the graph is opening either left or down. Because our axis of symmetry is horizontal, we know that this graph will be opening up left. Let's go ahead and find our focus. We'll be using this equation to determine our focus. So our focus is going to be h, which is 0, plus p, which is negative 3, comma, k, which is 0. Our directrix will be this equation right here. X is equal to h, which is 0, minus p. Since p is negative, a negative times a negative will be a positive 3. Now let's find our axis of symmetry. So our axis of symmetry will be this equation here, which is y is equal to k. And in this case, k is equal to 0. Now that we have all this information, let's go ahead and plot our points and graph. We'll start with the vertex at 0, 0, which is here. Then I'm going to go ahead and plot our focus, which is negative 3, 0. So I'm going back 3, 1, 2, 3, and I'm staying at 0 for my y. This will be my focus. Remember that our directrix is a dashed line, and it's located at x equals 3. So I'll be going 1, 2, 3. Remember that this is a vertical line, just like that. This makes sense since the distance between the focus and this vertex is the same distance as the vertex to the directrix. Now what we're going to do is go ahead and look at our 4p. Our 4p is 12, which means that the distance going through our focus is going to be 12. We're going to go 6 on each side. So from this point, I'm going 6 up and 6 down. 1, 2, 3, 4, 5, 6. Here's one point on our graph, and the other will be located 1, 2, 3, 4, 5, 6 right here. Now that I have these points, I can go ahead and graph my parabola. It'll look just like that. If you want to verify, you can make sure that the distance from the focus to that point is the same as the distance from this point down to the directrix. Since we went down 6, we're going to make sure the distance is 6 going across. So 1, 2, 3, 4, 5, 6, and it is. What it asked for was the points located here and here. We're going to go ahead and just label that negative 3, positive 6, and negative 3, negative 6. So the foci diameter here is going to be 12. I'm going to go ahead and write that down here. The focal diameter is going to equal the absolute value of 4p. So here we have negative 12, which is positive 12. And that completes this problem. This next section indicates the graph of the parabola with the vertex at h and k. These are the formulas that you get, but you do not get the graphs themselves. I do recommend that you remember if p is negative, it's going to be opening down or to the left. If p is positive, you're going to be opening up or to the right. Number 4. Number 4 says to graph the parabola as indicated. Okay, first thing I'm going to do is use my formula sheet and determine if this is going to be a vertical axis of symmetry or a horizontal. Here, because the y squared is first, it's going to match the horizontal axis of symmetry. So this means it's either going to open up left or it's going to open up right. When I look at the coefficient here, I notice that this is a positive coefficient. Therefore, it's going to be opening up to the right. So I'm going to put here opens right. Now I'm going to go ahead and find the vertex using the set of formulas here. Here our vertex is going to be h, which is associated with the x. That's the one on this side of the equal sign. It's supposed to have a negative here. Since we have a positive here, we're going to take the opposite. So it'll be negative 2, comma, k is going to be associated with the y. You can see that there's already a negative there, so we're just going to take the 5. For our focus, we'll be using this equation here. So I'm going to put focus. And here it says h. H is negative 2 plus p. Now, remember, we don't have p yet. We know that 4p is equal to 8. Therefore, p is going to be equal to 2. So I'm going to add 2 here. K, which is your 5. When I simplify this, I get 0, 5. Our directrix is going to be an equation. So remember, we have to identify it as an equation. It'll be the next formula here. So it's x is equal to h, which is going to be negative 2, minus p. So here we have minus 2. So our directrix is going to be x is equal to negative 4. And then finally we have our axis of symmetry, and that's going to be y is equal to k, and in this case k is 5. Okay. Now that I have all my information here, we can go ahead and graph. I'm going to go ahead and start with negative 2, 1, 2, and then up 5, 1, 2, 3, 4, 5. This is going to be our vertex. Our focus is 0, 5, so it's going to be right here. We have a directrix of x is equal to negative 4, so 1, 2, 3, 4. This is going to be that dashed line. And as you can see, the distance from the directrix to the vertex is exactly the same as the vertex to the focus. The next thing we're going to do is our axis of symmetry. That's going to be right here, just like that. So remember, we don't have any other points here, but we're going to use the focal diameter to help us. Our focal diameter is going to be equal to the absolute value of 4p, which is equal to 4 times 2 is equal to 8. So I'm going to take half this distance, which is 4, and I'm going to go up 4 from the focus, and I'm going to go down 4 from the focus. So here, 1, 2, 3, 4. That's one end, and then the other is going to be 1, 2, 3, 4. Here's the other. So now that I have these 3 points, I can go ahead and connect the dots, right? And our parabola will look very similar to this. Number 5. Number 5 says to write the equation of the parabola in standard form. Notice again, on this side of the equation, you only have one of the variables that is squared. So we're going to keep this variable, which is our y's, on one side of the equation, and we're moving everything else to the other side. So I'm going to go ahead and start with 4y squared plus 12y plus some number is equal to take this over to the other side, it'll get you a negative 16x, and then plus 71, plus, again, some number. If we add one number here, we're going to add another number there. Next thing I'm going to do is go ahead and factor out a 4, and I'm going to be left with y squared plus 3y plus some number. Now we're going to complete the squares. We're going to take this middle term and divide by 2. So 3 divided by 2, and then here we're just going to square it. That gets me 9/4. That 9/4 goes in this blank here. But remember, we're multiplying by 4, which gets us a 9. That's going to go in this other blank here. All I'm going to do now is go ahead and bring this down, but I'm going to have it in factored form. I'm going to use the variable y and put it right in front of that plus 3/2. So the 4 comes straight down, and then I'm left with y plus 3/2 squared is equal to negative 16x, and then add these two together, which gets me a plus 80. Next thing I'm going to go ahead and do is factor out a negative 16 from this side of the equations. Okay. When I do that, I get a negative 16x minus 5. Okay. Now what I'm going to do is divide everything by 4, because remember, when we're looking at our formula sheet, we don't see a coefficient on this side of the equation. We only see the coefficient on the other side. So let's go ahead and divide everything by 4. 4 there and 4 there. Okay. That's going to get me, and I'm just going to write it here, y plus 3/2 squared is equal to negative 4x minus 5. Okay. This is going to be your final answer. Number 6. Number 6 says to determine the standard form of an equation of the parabola with a focus of negative 5, 8 and the directrix of y equals 6. So here the first thing we want to do is go ahead and draw this out. Okay. The focus being negative 5, positive 8 means it's right here. I'm going to go ahead and label that focus. And we know the directrix is y is equal to 6. Okay. So here, if the focus is negative 5, 8, so if this is 8, let's use this as 6. We know the directrix is right here. Okay. Y equals means it's going to be a horizontal line, and this is the focus. So the first thing we want to do is go ahead and find the vertex. And remember, the vertex is going to be equal distance between the focus and the directrix. So I can say that the vertex, which is going to be located halfway between, is going to be negative 5, because it's still going to be on this line here, negative 5, and since this is 6 and this is 8, the vertex will be right in the middle at 7. So now we have the vertex here. Let's go ahead and find what P is equal to. Remember, P is going to be that distance. So the distance from one to the other is going to be P, and here it's going to be equal to 1. What we need to do is to go ahead and discover which set of equations we're going to be looking at. So since the directrix is y is equal to 6, we are going to look at the directrix equations and see between these two that it would match a vertical axis of symmetry. So we'll be using this set of equations. So I'm going to go ahead and write down the formula, which is x minus h squared equal to 4p y minus k. We have x minus h. Remember, h is going to be associated here with this negative 5, so negative times a negative makes a positive 5, and we're going to square that, and we're going to equal it to 4. P is going to be equal to 1. I'm just going to leave it as 4 here. I can do y minus k. K is going to be 7, so I'm going to plug that in as well. Alright, and this is going to be the standard form of the equation with the parabola with the criteria that was given to us. And you're done. Number 7 is an application of parabolas. It says there's a very famous logo consisting of the two golden parabolas. If a coordinate grid is placed over the logo, we can discover that each of the parabola intersects the x-axis 4 units from the center. So here's going to be a +4, here will be a -4. And the height of each parabola is exactly 8 units when measured. So right here, this height is going to be 8 when it's measured 2 units from the origin. So here's the origin. If I go out 2, and if I go 2 in the other direction, we have these 2 points. So it's basically giving us the vertex of each of these parabolas. This one here would be 2, 8, and this would be -2, 8. So that's how we want to start this problem. It says to find the equation of each parabola in standard form. So what we're going to do is we're going to start with the equation for the parabola on the right. So I'm going to go ahead and write here. This will be the right side. Right. So here we have a vertex on the right of 2, 8. We actually have 2 points here. We can use the origin of 0, 0, or we can use 4, 0, because each of these points is on the parabola. Now, personally, I think using the origin is easier just because it has a 0, 0. So we're also going to use a point on the parabola itself. Okay. Let's go ahead and find the equation. Remember, here we have an axis of symmetry that is going to be vertical, so we'll be using these sets of equations here. I'm going to go ahead and write the general equation out, which is x minus h squared is equal to 4p y minus k. First thing I'm going to do is go ahead and put in my h and my k into the equations. So I'm going to have x minus 2 squared is equal to 4p, and then y minus 8. Then I'm going to use that point 0, 0, and I'm going to plug it into my x and my y. So I'm going to have -2 squared is equal to 4p minus 8. Remember here what our goal is to find p, so we have 4 is equal to, multiply these two together and you get -32p, and then you can divide by -32 on both sides. Once you simplify this, you'll get a p of -1/8. Once you have your p, go ahead and plug that p into this part of the equation right here. So I'm going to have x minus 2 squared is equal to -4 times p, which is 1/8. Y minus 8. Let's simplify this. We're going to have x minus 2 squared is equal to -1/2 y minus 8. This is the equation on the right side. So now that we have the one on the right side, it's really easy to get the one on the left side, because the only thing that changes is the vertex. Here we had a +2, here we're going to have a -2. So all I'm going to do here is I'm going to basically write the same information. Our p stays the same. This will be the same for both. So what we're going to do is use this exact same information, but this time we're going to use the vertex. Let's put here left, and we're going to use the vertex of -2, 8. We're using the same p of -1/8. So we're going to plug it into this equation. X minus h squared is equal to 4p, y minus k. Then I'm going to have x minus, and -2 makes this a +2 squared is equal to, and then all I'm going to do here is multiply these two, which is going to still give me a -1/2. I'll go ahead and show it here. And then y minus k, and k is 8. Simplify, you get x plus 2 squared is equal to -1/2 y minus 8. And this is going to be the equation for the left parabola. Okay, this concludes the lesson for 10.3. Let me know if you have any questions.